All right, so good morning, everyone, to another Sunday morning session. So, first of all, wishing you all a very happy Mother's Day, right? I think your mothers have done a great job, in making what you are, today. They play an important role in what we all are, as individuals. So make sure that you make them feel special today, right? Very, very important, right? They play a great deal of role in what we are, as individuals. All right, cool. Now, what are we going to do today? So we are going to uh, still continue with our journey on measurements. So last week we did area. A week prior we did, uh, I think, perimeter circumference. Today, what we are going to do is volume, right? So which is pretty much the last leg of measurement. So we are going to do volume today, and we are going to deal with, excuse me, a lot of composite figures and their volume. Composite figures are always a challenge. Uh, so yes, so we will be dealing with volume today, right? And I'll have a look, in case I've got anything that's not picked up as a part, probably the delta. I will cover that, next week, right? So I'll have a look, at the curriculum. So at this point in time, the only thing that I can think of is volume to start with, and then we can cover off a few things that are left in measurements as a part of the next lesson, right? So yes, surface area could be one, time could be other one. So there are a few things that we can do, but volume is the core component. 36 people have joined so far. Good, a good strength as usual. We kick off, and I'm going to share my screen now. Good morning, everyone. All right, so I hope you're able to see my screen. All right, volume. So if we really talk about volume, what exactly is volume? So volume is the amount of space. Volume is the amount of space a three-dimensional object occupies. A 3D object occupies. It's as simple as that. It can also be how much, maybe I can say in layman terms, how much liquid can a 3D object hold? Capacity, maybe, right? So, a very common example of a 3D object could be a shoebox, right? Maybe a shoebox, a 3D object, something like that. We've got people still in. Let me just get them in, please. All right, so something like that, a 3D object, right? Not a perfect cube, but yeah, that's how it looks. Now, whenever we draw a 3D object, it says three dimensions. So the three dimensions are the length, the width, and the height. So in this scenario, that's the length, the width, and the height. So when we are measuring the space occupied inside or the space which is enclosed within this 3D object, we are essentially talking about measuring the volume. Very, very simple. Now, if we take the example of this particular object, which is a shoebox, in the world of mathematics, you can call it as a rectangular prism. So let's say the length is measured in meters, width is measured in meters, height is measured in meters. So if I have to find the volume of this particular shoebox, we all know, right? And this is not a surprise. So the volume of a rectangular prism or this kind of a rectangular 3D object is length times width times height. So you've got meters times meters times meters, which essentially means meter cube. So the units of measurement for volume is a cubic units. Now this units could be meters, centimeters, millimeters, kilometers, whatever, right? The main thing is cubic, which is the raised to the power of 3. So I can write it as units raised to the power of 3. Now, whatever this unit is, unit could be, as I said, meters, centimeters, kilometers, millimeters, whatever. Now let's go back to this rectangular prism or this shoebox and redraw it again. Now, that's how a rectangular prism looks like. If I look at the base, the base is a rectangle, a 2D figure with length as L and width as W. So what is the area of the base? Area of this rectangle or area of the base? Should I call it as base? Base is the platform on which your 3D figure is standing. The area of the base is length times width. That's fine. Now there's only one component which is not involved so far, is the height. So if you look at the formula that I've given here, length times width times the height. Length times width is nothing but the area of the base. So the volume of the rectangular prism is actually the volume of this rectangular prism, or the shoebox is what I'm calling today, is area of the base, which is length times width multiplied by height times the height. So whenever we are trying to find the volume of any 3D figure, we first need to calculate the area of the base. In this case, it is a rectangle, so length times. And then I simply multiply it with the height. So volume, the formula for the volume of any 3D figure is, area of the base multiplied by the height of the object. That is the general formula for the volume of any 3D shape. Now, let's take an example of a Pepsi or a Coke can, which is a cylinder. Now, this cane or a cylinder has the base as a circle. Base is a circle. And circle has the radius r. That is r, radius r. It also has height h. So if I were to find the area, the volume of this cylinder, I will apply the same technique. Area of the base. Area is the base is the circle. What is the area of circle? Pi r square times its height, h. So we all know, if you don't know, the area of the volume of cylinder is pi r square h. But I'm explaining you why it is pi r square h. We know it's pi r square h. We know the area, the volume of the shoebox is length times width times height. We know all that, right? We know, but why is very important. So that is the formula for the volume of the cylinder, pi r square h. If you know the area of the base, you know the height, multiply both of them and you get it. Now, if I have something like this, and I need to know the area, I need to know the volume of this irregular shape. If I know somehow the area of the base, and let's say the area of the base is, just hypothetically making up, 10 meters square, and let's say the height is 2 meters square. So then then the volume of this irregular sort of a shape is the area of the base times its height. So 10 times 2, which is 20 meters cube, 20 meter cube. So that's the very, very fundamental and basics of what volume is all about. Now, when we talk about conversions, so the units of measurements are kilometers, meters, centimeters, millimeters. Now we are talking about volume. So it's kilometer cube, meter cube, centimeter cube, and millimeter cube. Right? If I have to convert them into, if I have to, convert them into, kilometers to meters, I have to go from the higher units to the lower units, I multiply. 1 kilometer has 1,000 meters in it. But hang on, this is volume, a power of 3. So I have to multiply it by 10 raised to the power of 3. Similarly, 1 meter has 100 centimeters. So conversion from meter cube to centimeter cube is you multiply it by 100 cube. Similarly, 1 centimeter has 10 millimeters, so you multiply it by 10 cube. Now, if I'm going from lower to higher, I'm using the same values, but this time I'm dividing. So when you go from higher to lower units, you multiply. I've talked about it in my area lesson as well, in my perimeter lesson as well. You multiply. When you're going from lower to higher, you divide. Very, very simple. Now, if I were to quickly ask you to find me the volume of this cone, so this cylinder, the diameter of this cylinder is 6 centimeters and the height is 5 centimeters. Can you quickly calculate the volume of this cylinder for me now? Don't forget. Okay, let me just, before I say anything, let's see what people are writing it down. Can you please find me the volume of this cylinder? Area of the base times its height. I'm waiting for more answers. There are around 35, 40 people in here. Just answer once. That's it. One answer is fine. All right. So the answer is 45 pi centimeter cube. Anyone who's missed writing centimeter cubes, probably the answer will not be accepted. Please make sure that you have the units associated with your answer. 45 pi centimeter cube. And then you can plug in pi to get the answer. How do I find it? The area of the circle. The diameter is 3, so the radius is 6 divided by 2, which is 3 centimeters. And so the area is pi r square, which is pi times 3 square, which is 9 pi centimeters square. And then I just times it by height. So the volume is the area times the height, which is 9 pi times 5 is 45 pi centimeter cube. All right, now I'm going to put and then you put the value of pi and you get your answer. Okay, let's see how we do this one? I'm going to put a snippy here. Can you find me the volume of this particular object? Go for it now. (336 centimeter cube) is the right answer. Centimeter cube. Please don't forget centimeter cube. Right. Now, how are we going to do this? My base is a triangle. So it's a triangle with height of 8 centimeters and the base as 7 centimeters. So what is the area of the base? Area of the base is the area of the triangle, which is half 7 times 8. So half 7 times 8 is 28 centimeters square. And what is the height? So I just times it by height. So the volume is area of the base times the height. And height is 12. So you multiply this with 12, you get 336 centimeter cube. Good job. All right. And I'll give you an easy one now. This should be straightforward. Quick, tell me the answer. This was peanuts, right? Good. You're just multiplying the area with its height. So you're just timesing 13 by 7. That many centimeter cubes is your answer. Now, we talk about something called capacity. Now, capacity is if your 3D object is hollow. So the amount of substance it can hold, for example, a liquid, is called capacity, which is often the volume as well. Now, the word capacity measures, as I said, the amount of liquid your object can hold. And when we talk about capacity, which is nothing but volume in itself, we do not measure the capacity. The units of measurements are not cubic centimeters or cubic units, basically. They are more so measured in liters, milliliters, kiloliters, megaliters. So they are the liter, you know, the liter comes into the picture. So how does this liter thing correlate to the cubic unit thing? So there is a connection. So if I draw a, not the perfect one, but I'll try to. If I draw a square prism with 1 centimeter length, 1 centimeter width, and 1 centimeter height, what is the volume? The volume is 1 centimeter cube. And the conversion into liters and milliliters tells us that 1 centimeter cube is 1 mil, 1 milliliter. So let's see how the conversions happening. So if you have kiloliters, liters, milliliters, how do you convert them? They're all standard, stock standard, they're thousands. So there are 1,000 mils in 1 liter. So if you are converting liters to milliliters, you multiply by 1,000, and if you are converting it other way around, you divide. Similarly here as well, 1,000, and when you convert back, you divide by 1,000. There's another unit called megaliters. The M is capital. For the mils, the M is small. So the megaliters also has pretty much the same relation. It's easier to remember because you're just dividing stuff. And when it comes to the correlation between, or the connection rather, these liters and the volume, so I have 1 centimeter cube is 1 milliliter. So how much is 1,000 centimeter cube? Obviously, it is 1,000 milliliters. And what is 1,000 milliliters? 1 liter. Similarly, 1 meter cube is 1,000 liters, which is nothing but 1 megaliter. So just remember this. It is very handy when you're playing around between the volume, which is cubic units, to liters, milliliters, and kiloliters. Okay, let's do a few more questions now. Let me just pull something out for you, which is interesting. All right, let's do this one. I'll put a snippy now. All right, let's find the volume of this. Can you find me the volume of this block of cheese? Take your time. A few of the answers that I show that I've just seen are incorrect. So when you're answering, make sure that you are giving utmost attention to the numbers, please. Just a request. Still people joining in, which is a surprise. '84 centimeter cube. 84 centimeter cube is the right answer. Now, how do we get there? So, what is the first things first? That's the base for which the measurement's given to you. So, area of this triangle. What is the area of triangle? Half. Base is 5 and height is 4.2. And you multiply it with the height of the cheese block, which is 8. So when you solve all of that, you will get 84 centimeter cube. See, now there could be a confusion that what is the base? If you look at it, and this is a commonly asked question, the cheese block is sitting on this base, right? So shall I consider this as my base? No. Yes and no, should I say, right? It all depends upon what dimensions are provided to you, right? It is very, very simple. What dimensions are being provided to you becomes your decision factor of what base you are going to take. So if you look at it, this question, I'm given the complete dimension of the triangle. So that means if I invert this, as an example, this can stand, if I spin this 90 degrees, this will stand on this base. And therefore, this triangle is considered to be the base. Very, very simple to identify. If you're given all the parameters for a particular shape that you can find an area for, that becomes your base. Another one is the base is exactly the same on both the sides of the shape. That is another identification of how you can find what the base is. So if you look at it, and if I just take all this stuff off for a second, make it more cleaner. Look at this triangle and look at this triangle. They're exactly identical, opposite to each other. So that side of the three-dimensional block serves as the base. So there are a few ways that you can identify which is the base of your 3D object, right? All right. Let's try one more, right? Very, very similar. You need to identify what the base is and then give me the answer, right? Let's try this one. This is like the loaf of a bread, and I need to find the volume of this figure. Go for it, please. Let's see what answer do we get. Two, three, four, nine pi. Pi 2349. 2349 pi. Okay, all right. Right answer. 2349 pi is the right answer. I'll give a couple of more minutes for the others to do it who've not done that. And then I'll jump on to solve this. All right. So what is the base? Anything which is exactly similar on the opposite end. So this one, this and this looks to be the same. So that is my base, and not the rectangular, no, not the rectangle on which this bread is actually sitting. That's not the base. I explained you why. This is 1/4 of a circle. The base is 1/4 of a circle. So pi r squared divided by 4, a quarter of a circle. Radius is 18. So 1/4 times pi times 18 squared. And then times the height. That becomes my height. So when you solve it, I think whatever you got here was 2, 3, whatever, 4, 4, 9. Yeah, 2, 3, 4, 9 pi. Centimeter cube is your volume. Simple, easy peasy, right? Let me check one more. I hope this is clear to everyone, right? The stuff that I've just done. Everyone's fine with this one, right? The bread, the loaf of bread and its volume. Everyone's okay with that? Good. All right, cool. Let's go another figure and try to find its volume. Go for it, please. This will be some decimals, so yeah, so you have to do some hard work here. If you want to use your calculator, feel free to, and I'm allowing this because this might require you to use decimals, right? Give it a go, right? Give it a go. You can use a calculator here if you want, right? Okay, the formula for the trapezium, the area of trapezium is half sum of parallel sides times the height, which means half a plus b times height. So if I have a trapezium like this is A, this is B, and this is the height. So that's the formula. Yes, I now am seeing the right answer. 18562.5 centimeter cube. All right. So that's the area of trapezium. Yes. So how are we doing this question? If you look at it, identification of the base is very, very important. So that is my base. The opposite ends look similar. They are exactly the same. So the base is this trapezium. Let's plug the values in. Half. The first parallel side is 15. The other parallel side is 30. So 15 plus 30 times its height, the height of the trapezium so far, which is this height, the 15. So that is the area of the base. Now, if I multiply it with the height of the object, which means another 55 here, job done, finish. So what we are trying to solve here is that the volume is the area, which is half 15 plus 30 times 15 multiplied by the height of the shape. And when you solve it, then whatever you got, right, 18562.5, right, centimeter cube. Can I ask you one thing? Can you convert this 18562.5 into liters, please? Can you convert this into liters? Can you tell me how many liters would this be? I need to see how many liters, not the mils, liters. Liters. 18.5625 liters. Correct. Good job, LP. Yes, now I'm getting the right answer from everyone. This centimeter cube is nothing but that many milliliters, because I told you 1 centimeter cube is 1 milliliter. And how do you convert this milliliter into liters? Is by dividing it by 100. 1000, sorry, my bad. Which is 18.5625. All right. Now, something more challenging coming your way, right? Let's see how we go about it. We've got like roughly 12 more minutes to go into this session. Technically, the topic of volume is covered. It's just the composite shapes that we are going to play around. Please take care when you're solving this. I need to find the volume of this composite shape. Please go for it. Please take your time to solve this. There is no rush to the finish line, Rhythm. That's not the right answer. Take your time. Have a closer look. There are two figures here, not one. Now I'm seeing the right answer. I want others to finish this off, please. This is important. Still giving time to people. Yes. Seeing the right answer now. 131536 plus 300 pi centimeter cube. Cool. All right, let's quickly solve it. Right. This figure is basically divided into two figures. So if I were to sort of not draw it and quickly snippy the two figures, this is how it looks like if you look at it. This is what it is. If I were to split them, this is what it is. The two figures, right? So if you look at it, the cylinder sitting on the top and a rectangular prism sitting at the bottom. So if you now find their volumes independently and add them, job done. So volume of the first one is V1 and the volume of the second one is V2. Let's find V1 first. V1's got, I told you these lines means this is 16, right? So that's 6. So area of the base is 16 times. So basically 16 times 16 times 6. That's a rectangular box. Length times width times height. So this comes to 1536 centimeter cube. Now what about the second volume, which is a cylinder now? Cylinder's base has the radius of 5. So what is the volume of cylinder? Pi r square times height, which means pi times the base has the radius of 5 times its height, which is 12. So when you solve it, you get 300 pi centimeter cube. And the volume is V1 plus V2, which is 1536 plus 300 pi centimeter cube. Very, very simple, right? Has everyone got the hang of it, right? This was sort of a challenge, right? Okay, maybe the last question of the day, looks like. One more to go, and then we finish our session for today. I want you to find the volume of this figure. Go for it. It's not that difficult if done properly, right? Give me the final answer in pi. Don't give me this multiplication. Give me the final answer in pi, please. Give me the answer with units, please, Davik. 204 pi centimeter cube is what I am looking. Two hundred and four pi. 204 pi centimeter cube is what majority of you are saying. Let's quickly check this. Anyone who hasn't got this, type a no. I want to see how many hasn't got 204 pi. Okay. Have the courage to say no that I don't have it, right? It's okay. You know, we're all human beings. It's okay not to get the right answer every time. Even I get it wrong at times. Okay, anyone else who's got the courage to say no by any chance, right? Or this was too easy for everyone. And there are like 45, 46 people out there, 44. No. All right, no, no. All right. Let's quickly do it, right? Let's quickly understand what this is. And then the session is done for the day. Now, look, let's understand what this is. Let's understand what this is. There are three cylinders here. Cylinder number one, cylinder number two, and cylinder number 3. 3 cylinders here, right? Now, cylinder number 1 and cylinder number 2 are exactly the same. If you look at the dimensions, their diameters are 2 each, and their height is 6. Now, you see why my height is 6 is if I just take all of that off for a second, you've got 2 double lines here. So this is 6 as well. Now, the volume of this smaller cylinder, let's try to find that, and then we twice it. We get cylinder number 1 and cylinder number 2 sorted. So what's this? Pi. Now radius is 1 because you're given the diameter. Please make sure. Times the height. Height is 6. So that's cylinder number 1 here. So that's the cylinder number 1. Volume. And since it is exactly same as the second cylinder, I simply multiply it by 2. So this becomes 12 pi centimeter cube. Then the bigger cylinder, which is cylinder number 3 now, is volume is pi times r square. Radius is, the diameter is given to be 8. So 8 divided by 2 is 4. So 4 square times the height, which is 12. Now this will be 4 square is 16 times 12 pi. Now what is 16 times 12? 16 times 12 is, oops, 192 pi. And we just add them. So we just add them. So final volume is 12 pi plus 192 pi equals to 204 pi centimeter cube. With that, I come to the end of my session today. It was great having you today, Sunday morning. And thank you very much for joining. And I will see you back next week, same time. Now, before you all go, one